an object is placed 1.8 centimeters in front. Now the key word here is front. Okay? It's talking about the object. So it's talking about a position, so we're going to call it D or X if you prefer, of the object. Okay, this is the position of the object, and the key word was in front. Okay. Then it says here that, you see that? It says a focal length of 0.5 centimeters. So that one's pretty straightforward in terms of what it is. It's a focal length, so we'll give that the symbol of F. And then finally we have 1.5 centimeters behind. Now this is a new type of letter that we haven't used before in the problems with one lens. I'm going to call this B for behind or between. This tells us the distance between the two lenses. Okay, and this is important. Only for two lenses you have this number. Okay. So the next thing we have to do is work out what they're trying to find. And the question A says, where is the first image formed? So they're actually asking for the distance or the position of the image. Okay, and this is a straightforward application. Now, before, if we wanted to find DI, and we have F and DO, what would you use? You'd use this part of the lens equation. 1 over F equals 1 over DI plus 1 over DO. Okay, and we're trying to find DO here, so we put in the numbers for F. F is 0.5. Distance of the image is unknown, so we're trying to find this one. The distance of the object is 1.8 centimeters. So far, let's write down what we've got here. If the object of these two lenses starts over here, we have got DO, the distance of that object, and we have also got F, the focal length, which we'll put here, and we have also been given B, which is the distance between the two lenses, and then we've just worked out DI, which is the distance to the first image. We'll say the image, for example, is here, and that is DI, the distance to that image. So far we've only dealt with one lens here. So what I want to do is label everything from the first lens with the number 1, just so we don't get confused in a minute. That's the object of lens 1, that's the distance of the object from lens 1, that's the focal length of lens 1, that's the distance of the image from lens 1, and that is the image from lens 1. Now we come to the bit where we deal with the second lens, and notice how this sentence here says this first image will now serve as the object for the second lens. What does that mean? That means that the first image we just worked out here, the image for the first lens, will now actually be the object that we'll be using for this lens. So we're going to expect, for example, the image of that lens to be somewhere over here. We'll call it image 2. Okay. So the first thing we need to do is find the distance to the object for the second lens. So that means this distance here. We need to find this DO2. And there is a simple formula for that. And this is one of the new formulas you have to learn for two lenses. Okay. That formula is DO2 equals to B, the distance between the two lenses, minus the distance to the image of the first lens. So the distance between the two lenses, B, we said was 1.5, and the distance of the image for the first lens, this one here, we worked out over here. So that answer, you'll put that there, and then you'll get your distance for the object 2. And once you've got your distance for the object 2, you can write that on your list of numbers you have, that answer there. You'll also have the focal length for the second lens, and in this case it was identical, so the focal length of the first lens was 0.5. So the focal length of the second lens actually happens to be the same, and it will tell you in the question it's the same. So we'll put the focal length of the second lens there. And we'll write that in again, 0.5. And then the next question it asks will be, what is the distance to the second image? Okay. What is the distance to this image here? So that distance, to calculate it, will be exactly the same way you calculate the first image, okay, using this formula here.